Very good. Let us take a look at this example. Question says, solve the following differential equation. So the differential equation given to us is the second derivative of y. This is what we try to solve, the second derivative of y minus y prime plus y equals to 2 sine of 3x. Okay. We have a non-homogeneous second order differential equations with constant coefficients. How do we solve this? So first of all, we need to divide this up into two parts. We need to find the complementary function yc by setting this equal to 0. So the possible solution is e to mx. So we get m squared e to mx minus m e to mx plus e to mx equal to 0. Factor out e to mx. M squared minus m plus 1 is equal to 0. So e to mx, as we know, it's not 0. So the auxiliary or characteristic equation is m squared minus m plus 1 is 0. So m is negative b plus minus square root of b squared minus 4ac divided by 2a. So m is equal to a half plus minus I square root of 3 divided by 2. So your alpha is a half and beta is square root of 3 divided by 2. So y sub c, or the solution, general solution for the homogeneous part, is equal to e to x over 2 parentheses c1 cosine square root of 3 divided by 2 plus c2 sine square root of 3 divided by 2. So this is y sub c. Now we need to find y sub p and then add them together to form the solution for this differential equation. So now y sub p. For y sub p, all depends on g of x. Y sub p depends on g of x. What is g of x? G of x is 2 sine 3x. So let us look at the classification that we have. If you have a number, a constant, whatever, times your sine, here your constant is just 1. The particular solution is the combination of sine and cosine. So since, write it this way, since g of x is 2 times sine 3x, then particular solution y sub p can be written as, here we have c1 sine of 3x plus c2 cosine of 3x. But our job is to find c1 and c2. Again, guys, when you have particular solution, you cannot have any parameter. What is a parameter? Like missing values, c1, c2, anything missing cannot be part of your particular solution. So we need to find the derivative of yp and the second derivative and plug that into the differential equation. Y prime p is 3c1 cosine 3x minus 3c2 sine 3x. The second derivative of p is equal to negative 9c1 sine 3x minus 9c2 cosine 3x. Okay, substitute in the differential equation. So let's see what do we have. So we're going to copy this right down. Negative 9c1 sine 3x minus 9c2 cosine 3x minus y prime minus 3c1 cosine 3x plus 3c2 sine 3x plus y is c1 sine 3x plus C2 cosine 3x. What is on the right-hand side? On the right-hand side, I have 2 sine 3x. 2 sine 3x. Pure algebra. So here you need to identify what are the coefficients of your sine r. So I have sine 3x, I have sine 3x, and I have another sine 3x on the left-hand side. And the coefficient of sine 3x on the right-hand side is 2. What's the meaning of that? It means that negative 9 C1 plus 3 C2 plus C1 is equal to 2. Well, I do not have any cosine on the right-hand side. It means that I have 0 times cosine. So this guy is negative 9 C2, this guy is negative 3 C1, and I have another C2, so negative 9 C2, and minus 3 C1, and plus C2 must be 0. We have a system of linear equations. If you combine these, what do we get? This is negative 8 C1 plus 3 C2 is 2. And then here, if you combine these two, negative 8 C2 minus 3 C1 is equal to 0. So if you solve this guy, here you get 3 C1 negative 8 C2, or C1 is negative 8 thirds C2. Substitute that in the first equation to solve for C2. So just check this here. We get 64 divided by 3 C2 plus 3 C2 equals to 2. So this is 73. So C1 is negative 8 over 3, 6 over 73. We get 2, negative 16 over 73. So the general solution can be written as y sub p equals to negative 16 over 73 sine 3x plus 6 over 73 cosine 3x. Well, by adding these two together, you get the general solution for this differential equation. Y is yc plus yp.